Hello and welcome to the 6th episode of our drone show and swarm project series, powered by PX4 and MAVSDK. In this episode, we are stepping up our game with an advanced multi-level leader followership mission using not 2, not 4, but 12 drones simultaneously. Now if you're joining us for the first time or if something doesn't quite click for you, you might want to go back and watch the previous episodes in this playlist. We've built everything from the ground up and each episode lays the foundation for the next. You can find the links to the playlist in the description below. Our journey began with a simple off-board control example using MAVSDK. And from there, we've been steadily ramping up the complexity. We've created coordinated flights for the single and multiple drones to draw fascinating shapes and animation in the sky. We then ventured into the realm of a smart swarm operation where drones can communicate and interact with each other in flight. We started off with a simple leader followership example. In this video, we are updating to version 0.6 where I've significantly optimized the command and data handling system, which is CDH. Now, it's capable of handling a large number of drones in real time, ensuring a smoother and more coordinated flight. To make the setup and testing process a piece of a cake, I've used Docker. We've created a Docker image that lets you create as many drones as you need, all with necessary software installed and initialized such as PX4, MAVSDK, Gazebo simulator, software development environment, and everything you need in a matter of seconds with a single command. This keeps everything portable and easy to test. Now I won't dive deep into Docker concepts and coding details in this episode to keep things focused, but don't worry, we'll be covering that in the upcoming videos. If you're not familiar with the Docker yet, I've got you covered. Check out the links in the description for some great Docker tutorials videos. My recommendation is Network Chuck's. His videos is great in all topics, in all IT topics, he's the best. So without further ado, let's dive into our two demos and see the new features in action. Let's get started. First, I'm gonna show you what has changed in our project since last time. On the right side, you can see our project directory. We have good old config.csv and swarm.csv file that we had before. Let's see how we change it for our demonstration today. Let's open config.csv, and as you can see, we have 12 drones. Initial position is not important in a smart drone operation. So we have 12 drones. Each one of them has an individual separate IP address. This IP address is important. These are being initialized by the Docker instance. And we have the auto-generated map link and debug ports for the communication. And the ground control station is the same for all. This is the IP address of my Linux virtual system. The other file that you need to change is swarm.csv. Again, we have 12 drones. In this example, we have only one leader. Drone 1 is leader, and the other 11 drones are following the drone 1. And creating a shape in the sky, if you can imagine, it would be something like an arrow. So let's go ahead and run it and we'll see it in action. Let's see what file has changed since the last time. If you open the folder multiples SITL, you will see some automation files here. For example, set sysid. If you remember in the last YouTube tutorial, you know that we went to the PX4 autopilot RCS file and manually changed the maplink sysid to be the same as the hardware ID. Here, all these things happen automatically for you. So there is another file which is a startup software in the loop that is gonna find the hardware ID file. It's gonna initialize the maplink sysid. With that, it's gonna git pull from our GitHub repository to make sure our configuration is online and synced with all the drones. Then it's gonna run the multiple software in the loop, Gazebo simulator, and then it's gonna run our coordinator Python. That's it. We're just gonna relax and see just with one file everything is gonna happen for us. Then there is this magic file which is create Docker. This file is gonna create as many as Docker instances that we want. Each one of them is an image, is being created by this image. Drone template -1. I'm gonna share this file for you and I'm gonna describe what is happening, the magic behind the Docker in the next tutorial maybe. But if you know Docker, you know what is happening. We're gonna create as much of instance that we like. Each one of these instances is a separate Ubuntu version based on Docker. And this script is going to create each instance, and it's going to create the hardware ID, sys ID, and everything for us. So now we don't need to do anything. Let's see it in action. I'm going to fire up the QGround controller station. On the right, you can see QGround controller station is on my Windows subsystem, and the left side is my Ubuntu system. And I'm using Portainer to just visually see the containers and Docker instances visually and get a sense of what's happening. All you have to do is just go to our GitHub repository, which is good old MAVSDK drone show. Let's do a git pull to make sure that everything is updated. And all you have to do is just type sudo bash multiple_software in the loop and create docker.sh and the number of drones that you want. We need 12 drones. And if you have the Docker installed and you have the Docker image, all the magic is gonna happen from now. As you can see, 12 drones is being created, and you see that each one of them step by step is gonna be connected to our QGround control station, and our control station on the left side. In the bottom left, you can see our debug control station, and the new nodes are being appeared one by one. And the drone QGrounds are also connected to the drone. I'm gonna fast forward the video from here. You can see 12 drones have been created. We are getting telemetry from all of them, and all of them are connected to QGround control station. On the bottom left, there is all sort of telemetry packets that are coming at 2 Hz, so it's crazy. We should create some GUIs for that soon. Let's take these drones manually to take off. Again, I'm gonna fast forward the video. I'm gonna manually tell each one of the drones individually to take off and hold position and be ready for the mission trigger. Remember the concept of our drone show. Remember the concept of our swarm. All of the drones are by their own until we trigger them. From the ground control station, we're gonna send the command, we're gonna send a trigger time, and at that trigger time, the swarm operation starts. Now all the drones have taken off, and they are holding their position at 10-meter altitude, and they are ready for our next commands. We can either have a drone show, or we can have a smart swarm, or we can have a simple leader follower, or in this case, we're gonna have 1 leader and 11 follower. We triggered the mission, and finger crossed, and let's see what's gonna happen. They should create the shape that we generated in swarm.csv, something like an arrow to the north. And that's it. Vehicle 1 is the leader, and all other drones are creating the arrow shape for us. And we see this beautiful shape in the sky. Right now the fun parts begin. We can command the vehicle 1. You can see vehicle 1 is in hold position, and all other drones are in off-board position. It means they are following drone 1. And now I command the drone 1 to go to somewhere else. And as you can see, all others have rotated and they are following drone 1. Up until here, you might feel that nothing has changed since the last video. We had 4 drones in the last video, and here we have 12 drones. What's the difference? I have done many optimization on the communication side. The communication is now error-proof, reliable, but it's still not ready for real-world operation. But now telemetries are being communicated much more smoother, and they are much more reliable and faster. As you can see, 12 drones are creating this shape. They are rotating around the point, and they are all maintaining this shape in the NED, North Earth Down coordinated system. And everything is happened using the power of Docker. Each one of these drones have an Ubuntu version in Dockerized world, and all of them are individually simulating an environment together, and they are communicating on a network together. It's really crazy. The things behind the scenes is very crazy. Okay, let's go to our second demo. But before that, let's see how we can remove the environments that we have created. The power and magic of the Docker is just visible here. Using Portainer, I'm gonna just click each one of the drones that I want. I can delete it, I can stop it, I can restart it, I can rename it, or anything that I want. Each one of them is a different set of different drone system. So let's, for example, select all the drones and delete it, completely delete it. And for the next demonstration, again with just one command, we're gonna create all these drones and everything would be initiated for us with just one command. I'm gonna click on remove, and I also remove the partitions for them. And done. Right now you will see that ground control station communication would stop. As you can see, communication is lost, and our ground station has also stopped. It means all the drones have gone away. This is the power of Docker. This is what you can do with Docker. In the last video we used VMware. VMware is very good, very basic and very easy, but you can't run 12 instance of VMware Ubuntu. Although my PC right now is very beefy PC, it's Core i9 with a 24 cores and 32 gigabytes of RAM, and everything is at the top, but it cannot handle that. But with Docker we can do much more. Let's go to the second demo right now. Let's go to the second demo, which is my own favorite. This time we're gonna have separate group of drones. You don't need to do any modification in config.csv since we again have 12 drones. But in swarm.csv, all you have to do is to change the connection and arrangement of the drones. In this example, we're gonna have 3 groups of drones, 3 separate group of drones. So drone 1 would be leader of the group A, and drone 2, 3, 4 would be follower of the drone 1, and drone 5 would be the leader of group B, and drone 6, 7, 8 would be the follower of drone 5, and so on. You could even have some master leaders that even the leader drones, which are drone 1, drone 5 and drone 9, would have to follow the master leader. That would be really fun. But for this example, I want to have different swarm groups. Each one of them has its own application. It depends on your application, depends on your mission. This is very fun. You're gonna sit on your ground control station. You have a bunch of drones in the sky. Each one of them are separate, and you can command each group to go anywhere you like. This is a fun project. It can be very useful in agriculture missions, mapping, surveillance, drone shows, or any other missions that you need to have a bunch of drones in the sky can communicate together, do a cooperative mission, and so on. Just for visualization, let's arrange the drone groups as well. For example, to group 1, 2, 3, and both let's have all 3 have the same arrangement. Some random shape, maybe 3 meters to the southwest, then 3 meters to the northeast, and 3 meters to the southwest for each group. And let's change the altitudes. The group A would be the lower, group B would be the middle, and group Charlie or C would be the top group in the altitude. And that's it. That's all you need to change. Let's push it to our repository. Make sure if you want to push to the GitHub repository, you should create your own forked version. So make sure you know the GitHub concept, fork from our original GitHub repository, and that's it. Then you are good to go. All you need to do is just sync our GitHub repository and run the single command which we used in the last example as well. We're gonna use a multiple SITL and create Dockers 12, which will create 12 instances of our drone. Let's fire up our ground control station and run the command. Just for simplicity, I have added 5 seconds delay between each instance, but you can remove that delay as well. That's it. We run the command. Drone 1 is initiating, and so on. Just grab a coffee and return to your system when all 12 drones are ready to fly. Our command ground control station is connecting to the drones one by one, and Q ground control station is also connected to drones one by one. I'm gonna fast forward the video, manually set each drone to take off, and let's see what will be happen right now. You can see all the 12 drones have taken off and holding position at 10 meters. In this example, let's separate our groups before sending any mission. Right now, nothing has been triggered. No mission has been started yet. All the drones are just hovering and waiting for our commands. Let's separate the drones. We know that drone 1, drone 5, and drone 9 are our leaders. Let's send them to a predefined position. For example, I'm gonna send drone 1 to the northwest, and drone 5 to the northeast, and drone 9 to southeast or east. And all other followers are just hanging around. They are commanded to hold position and be a standby until we send further commands. Remember the concepts of our mission. Whenever we want the mission to be started, no matter it is a drone show, a simple leader follower, or a very complex mission, we're gonna send the command from our ground station. We're gonna type S for smart drone, and we're gonna give a trigger time. When you give a trigger time, as we're gonna do right now, each drone's state would be changed from idle to armed. And then each drone's gonna wait until their times come, until the trigger time comes. Okay, let's right now we can send the commands to the drones, each of them right now at idle. I'm gonna type S for smart drone and type 10 for 10 seconds from now. Right now we can see that the state of all of them has changed to on, and the immediate time that it's become triggered, we expect to see each drone go to its group itself, and voila, it's happening right now. You can see they are divided to their groups, and they are joining their leader. Very astonishing view. This is my first time seeing this result with this many drones, so I am as much as interested as you might be, or even more. So we have 3 groups of drones in the sky, 3 separate drones that they are all under our fingers. We can control them where to go and what to do. Let's define a mission for each of them. For example, let's tell the vehicle 1 to have an orbit here, a small orbit maybe. Don't make me wrong, you don't need to just send them to orbit. You can send it to a surveillance mission, you can send it to grid search, you can send it to look for something, look for example for survivor, look for fire, look for criminals, or any other mission you can imagine. I'm just gonna let them to orbit here because it's the easiest thing we can plan in here. You can go to the plan view and plan a complex mission just for the leader, and the followers would do it and follow it. Let's set the group Charlie to a bigger loop, and that's it. That is the mission that we planned. Very beautiful. All of them are passing and doing their own orbit, and let's enjoy the view. Okay, let's imagine that in the middle of this orbit and hanging around you see something, a survivor. Maybe you're looking for a survivor in the sea, in the ocean, or anything. You want to send one of the groups to that place. Let's send the group Alpha to the position that we found them. And other groups might return to base or go for another survivor or another target or anything that you might think of here. You're gonna find the target, and this target can be a survivor, can be an object that you're looking for, can be a criminal that is doing something that it shouldn't do. It can be maybe a sport event that you want to follow something, and that's it. That's the power of it. You can plan any mission that you like. Okay, let's terminate our mission. Let's terminate our software in the loop environment. Again, we select drone 1 to 12 and simply click remove. And all we had done is just delete it. And we don't need to take care about anything. All the Ubuntu version, software in the loop configuration, hardware codes, Mavlink codes, anything is deleted, and QGround control station and our debug control station are being terminated. Very simple. Again, whenever we want, with just one simple command, we're gonna create this Docker instance. The magic point that's make the whole easier for us right now is the Docker. Docker is doing everything behind the scene. I hope you have enjoyed this video. If you don't know about many of the processes that we're doing here, such as Docker process or container or portainer, make sure you watch the videos, especially videos that the guy, I love him, Network Shark, is creating. I'm gonna put the link for his videos about Docker. He's the best and he described Docker concepts better than anyone. I think I love this guy. Go ahead and watch this video to get a sense of the Docker and this kind of things. Maybe in the next videos, I'm gonna go in more details and tell you what is happening inside this code. But since I thought maybe it's become much more advanced, maybe some of you will be bored, and this video, although this video is still very long, and if I wanted to go to the detail, it would be much more longer. So I decided to just demonstrate what is happening in this video. Maybe in the next videos I'm going the details of what is happening inside each of these Docker containers. And the version that we demonstrated in this video is based on version 0.6. In the next videos, maybe I'm gonna give you the image file for software in the loop environment as well. Until then, have a nice time, and let me know if you have any comments or suggestion or recommendation or any advices in this project. And feel free to post it in comment section or contact me directly. And make sure you follow this YouTube channel for the upcoming videos about this swarm missions, that smart robot, aerial robotics, because in the next steps we're gonna make these robots much more advanced. We're gonna let them decide what to do, not just following. We're gonna add some smartness to our swarm as well, so make sure you won't miss them in the next tutorial. Have a nice day and have a nice time flying.